welcome back Richmond. Alake, who gave a workshop yesterday that got amazing feedback, so high expectations now, Richmond. But this is a really interesting one, because there's a lot of talk about context engineering, but memory engineering is just as important, but actually far less talked about. So really looking forward to this session. Richmond is the Director of AI Developer Experience at Oracle, and we're very, very happy to have him here with us. So please welcome on stage, Richmond.
Yeah, I'm Richmond Alake. Nice to meet you guys. Thank you guys for coming here today to hear my talk. I call it propaganda, but hear my talk on memory engineering. So we've kicked off. So there are two types of people in this room right now. There are those that get it and those that don't. I'm going to talk about what it is in a second. And the split is also within the Gen AI industry as well, within this Gen AI application development. So there was this report. How many of you have seen this report, the Gen AI Divide from MIT? Nice, a couple people. And the TLDR is 95% of organizations are not realizing value from their Gen AI initiatives, and only 5% are. And that is this divide within the industry. So there's a divide in this room, and there's a divide in the industry. And the dividing line from the Gen AI report was memory, intelligence, and capability. So the 95% that didn't realize value from their AI initiatives and the 5% that did, the main difference between them was these Gen AI applications that they had some form of adaptability, learning capabilities, and memory. So they were building agents with memory. So the folks that actually get it in this room were at a workshop yesterday. I see some of your faces here. So they get it, but by the end of this talk, we're all going to be on the same level. We're all going to understand memory engineering and maybe understand how you can actually go away and explore this topic in your own time. My goal is to get more people understanding how they can actually start to close that dividing line, how they can move people across the Gen AI divide. And that's through memory, adaptability, and learning capability. So today I'm going to be talking about memory engineering, and I'm going to be describing it in a way that we can understand, maybe through the lens of context engineering. So how many of you have heard of context engineering? Hands up, pretty much everyone. So think of memory engineering as context engineering ++. All right, so quick intro to myself. I'm a learner in the AI space. I've been learning different stuff, and when I learn, I teach as well. And I've been teaching on platforms like O'Reilly for several years. I used to write for NVIDIA as well. Some of the articles are still up there today. And there's a couple of talks I do like this on YouTube. And I've also taught a few courses with a few folks, Deep Learning AI, Imperial College Business School in the UK, and other platforms as well. The key thing is, and the next kind of shift in what I'm educating people on is AI memory management for agentic system. In my personal opinion, this is the last job to be done for engineers within AI. And after we solve this, we're good. It's AGI. So let's go. The talk is memory engineering going beyond context engineering. And we're just going to kick off with understanding this evolution, right? We went from prompt engineering to context engineering, and I'm about to take you to memory engineering. There's going to be a bunch of keywords that I'm going to be sharing across my talk. The key thing is, I want you to take away some key ideas. One, I want you to understand the job to be done. And the way that I can explain the job to be done for you guys building agents, I have to take you back in time to explain prompt engineering and also explain where we are now with context engineering. Then we can understand where we're going to go to with memory engineering. So there are three main ideas I'm going to give you. The first one is prompt engineering is maximization. Put your hands up if you understand what I mean when I say prompt engineering is max. Yeah, people that were there yesterday understand. But the point is, the techniques in prompt engineering, what we did was trying to stuff in as much tokens or words into the context window to make sure that these LLMs that we use actually give us the correct output. So there were a couple of techniques. We'll start off with an example of a prompt. So this is a prompt. Can you recommend some good holiday destinations for me for the summer? So this is an example of a prompt. The prompt engineering techniques we're using, such as few shots examples, hands up who knows few shots examples, the prompt, okay, nice, good. And what it means is you're giving the LLM awareness of some examples of the way you want it to respond. And the more examples you give it, the more it would respond in the format that you desire. Now that's few shot prompting, right? Again, maximizing. You're trying to put as much information into this context window. Then there was chain of thought reasoning. Hands up if you've heard of chain of thought. Yeah, same amount of numbers. So chain of thought, you're essentially allowing the model to think step by step through its process, right? So again, maximization of token stuffing the context window. And then there is the React prompting. There's a lot of React agents, which means it's just prompting that essentially elicit reasoning, but takes it a bit further and allows the LLM to look at to have a thought about a query, take an action, then observe the output, then decide on the next action to take, right? The action will be governed by some form of tool, then the observation will be the observation will be looking back into the tool results. Then you could go for the process again of thinking about the observation, reasoning about it, taking an action, then until you get your LLM giving you a final answer. Again, maximizing the amount of prompts we put into the context window. So what is prompt engineering? Prompt engineering is wordsmithing, right? It's finding the linguistic patterns that actually allow you to make the LLM useful and predictable in some sense. But the limitation with prompt engineering that we found out very quickly was it didn't describe the job to be done. So prompt engineering didn't really capture the work that a lot of AI developers were doing. And what was that work? There were a couple of people in the space that agreed, especially when context engineering came out, they agreed that prompt engineering was too broad of a term, probably a term that was captured and sensationalized by the media, and it became too over. It didn't really capture the complexity of what we had to do as AI engineers. So people thought it was mainly crafting clever sentences. But what it really was this systematic thinking of things we put into the context window, giving information to the context window through techniques like retrieval augmented generation. It was extensive constructions of retrieval pipelines. So there was a hidden form of engineering behind prompt engineering. Anyway, everything ended up with this piece saying, hey, prompt engineering is dead. There are other limitations, such as fragility of actually prompting techniques. So if you were to change a word in your prompt, it would change the output, and we couldn't use that in production. There is also a context ceiling. There's a context window length within all the LLMs we use today. But the key takeaway is prompt engineering is maximization. So do you guys agree that prompt engineering was maximization? Or is maximization? Put your hands up if you agree. Okay, good number. Let's go. Next one. Second idea I want to give to you today. Context engineering is optimization. So maximization didn't get the job done. So we moved to this space of optimizing the context, the information we're putting into the context window of the LLM. So context, very simply, is information about the scenario that we're trying to operate in. So if you have a prompt, so remember this prompt? Yeah, if you have a prompt, you would add more information that gives the LLM an understanding of the scenario that the prompt might be referencing to. So for example, for the holiday destination, I could give the LLM context around the user likes and dislikes, previous holiday destination that the user has gone to, previous interaction the users had with this assistant, this travel assistant. So that is context. Anthropic's piece on context engineering actually talk about the difference between prompt engineering and context engineering. And it's a good piece. How many of you have read this or seen it? A few folks, which is good. It means that there is still some good folks that can actually go look at that piece. The key takeaway, there are a couple of key takeaways. One of the key takeaway was they kind of described and summarized the shift, which is we moved away from finding words to describe the prompt or finding words for our prompt, and we've moved into finding the right configuration of context to pass into LLM. So context engineering is configuration, right? This is more systematic. This is more programmatic. And I've looked through a bunch of blogs and articles and papers from teams like LangChain, Anthropic, Manus, OpenAI, and there's some common themes around the techniques we're using. I think we're all converging into common patterns. So this context engineering flywheel. It touches on 6 particular themes that I'm seeing. One, which is context window utilization, but another one, which is context organization. And context organization actually makes a lot of sense to me because the human brain itself is organized, right? AI is the replication of human intelligence. The human brain in some form is organized in itself. So the context, the information that we're given to these LLMs should have some form of structure, should have some form of organization. Then there is context retrieval. How we retrieve context from data stores and databases and file systems is important, and what retrieval we use when and where is also important. So there's a bunch of techniques, engineering techniques that have been introduced by these teams. Some teams are not using all of this, some are using one or more of this. I'm going to be putting out a piece very soon that touches on all of this context engineering techniques. But the key takeaway from the Anthropic piece, which, again, you guys should read, is context engineering is a bunch of strategies for configuring the context window, the context that goes into the context window of the LLM, but also finding the optimal tokens that can actually allow us to get the desired behavior from our LLMs. So, context engineering is optimization. There's a bunch of limitation because, in my personal opinion, context engineering doesn't capture the job to be done. Because when I was talking to a bunch of engineers, right, and I was talking about improving their agents and their RAG pipelines, we were talking about retrieval, reducing latency by putting techniques like pre-filtering or post-filtering. We were talking about quantization. We're talking about hybrid retrieval strategies, right? When you use vector search with your keyword search. So it wasn't merely context engineering. Now, there are other limitations with using context engineering to describe the job to be done. I'm going to be putting out an extensive piece that talks more about this. But the key takeaway is, with prompt engineering, what we're doing was front-loading cognition, right? With context engineering, we're just trying to work only with this short-term form of memory, the working memory of the LLM. But with memory, which is what we're going to talk about, with memory, we go a bit further. So the key takeaway, the second one was context engineering is optimization. The first one was prompt engineering is maximization. Memory engineering is continuation, right? So humans, I'm going to reference us a lot, us humans. Humans have this incredible organ or wherever it is in our head, the brain. It's been developed by nature, and it's one of the best forms of intelligence we have on this planet. And of course, I'm biased. But the human brain itself has different forms of memory, right? I can tell you my phone number now, and you will remember it maybe for the first 5 seconds, and by the end of this talk, you're going to forget it. That's your short-term memory. And if I ask you to think about the last birthday you had, you could remember it. That's a long-term memory, and it's more specifically episodic memory. If I tell you to think about the color red, maybe you're thinking about blood or roses. You're thinking that's associative memory as well. So there are different types of memory in human, and we still don't understand how memory works in our brain. Is an area of research. Neuroscience is a thing. But we can still take inspiration from nature, just as we did with other forms of technology, right? So you look at planes today, they don't flap their wings, but the early attempts at flight had devices where we were flapping wings, but the plane that I took here wasn't flapping its wings. Thank God for that. But yeah, so moving on. I want to talk about agent memory, right? Because memory engineering is the discipline. This is the engineering discipline, but what are we actually engineering? Well, what are we acting upon? We're acting upon agent memory. And agent, how many of you have heard of the word agent memory before this talk? I want that number to increase. Wow, okay. I need to do more propaganda and more talk, so let's go. Agent memory is essentially the components where data and information moves through within an agentic system or an AI agent. So within an agent memory, you have three main components. You have the external memory. This can be a database, right? It could be a file system. But you also have a second component, which is a context window of the LLM. Then you have the parametric memory, which is the model weights and parameters within the LLM itself. That never changes. That's static. No matter what you do in your agent, that is not going to change yet, except if you go down the route of fine-tuning. So there are three components of agent memory. So agent memory, the way I describe it, is a computational exocortex for AI agents. And there are different forms of agent memory. I'm not going to go through all of this, and I should remove this because that's going to be annoying, but we're not going to relaunch Chrome. Let's see, can we escape this? No. I have to go back into Slideshow. Okay, so there are different types of memory. So there is short-term memory, which I just described. It's temporary. It's not going to persist through sessions. It's limited. People call it scratchpad. An example of what a short-term memory is the working memory that we have, which can be the LLM context window or some session memory. Semantic cache is also a form of short-term memory. Has anyone heard of the word semantic cache before? Okay, those that haven't, follow me on LinkedIn. We're going to talk about semantic cache very soon. I don't have enough time to explain. Those at the workshop yesterday, they understand what semantic cache is. And I'm going to give you some material as well. Long-term memory is obvious. It's memory that lasts and persists across different sessions for long horizon tasks. So agents need this as well. Coordination is a special one. When you have a multi-agent system, you need some form of memory space for them to act with each other and communicate with each other. So this is something we discovered we needed for multi-agent system. So what is memory engineering? Let's define it. Memory engineering is the scaffolding that we have to build to move data and information across the three components of agent memory that I just pointed out to you. That's what memory engineering is. That is the job to be done. It's the job that we do today. For those that are in the front lines, that are actually looking at agent memory and making agents actually work in production, it's the main job they're doing. So to define more of the job that we're doing, and you're gonna get the slides. To define more of the jobs that we're doing, you can think of this memory engineering lifecycle. A lot of the folks that are building these systems, we're ingesting data, we're taking data and converting it into embeddings using an embedding model, we're storing the embeddings and the data into a database. Then we're also organizing that data. Data modeling is very important when you're working with AI agents that you want to make more reliable and capable in production. Then there's the retrieval aspect. Vector search is not all you need. You need to think about hybrid search. You need to think about quantization and ways you can optimize your retrieval pipelines. Then you think about the LLM processing and inference. And this is the part where we actually need to educate more people on is the information you get out from your LLM, you can feed it back in. You can store that into your database with some form of structure, and it can be reused as well. So you have this cycle of information passing through your system. Okay, prompt words. Context, we're trying to explain the world behind the words. But memory, and that is blocking memory, but memory is a better way to describe what we need from AI today, which is personalization, which is I want my AI agents to remember my preference. I want them to remember the interaction. So memory feels like a very better word to describe where we're going towards. So prompt engineering is words about the world, right? It's phrases that we want to use to describe the world. Context engineering is world building. It's the word we're using to tell the LLMs about the world we're in. But memory engineering is persistence. It's making sure that world that we're describing continues and develops. So we understand memory engineering, and so do a lot of people in the front line of this space. So this came out from Google last week, or maybe, yeah, last week. The team at Google were talking about context engineering. They should have called it memory engineering because they just talk about sessions and memory, right? They don't talk about some of the context engineering flywheels that we included. And this came out from Cursor a few weeks ago talking about how they improved their system using semantic search and actually retraining the embedded model, fine-tuning the embedded model using agent traces. Then this came out from Anthropic. The key thing is, a lot of people in the front line are realizing the job to be done, but we just need to describe it because description of what we do as engineers is very important. So, the key takeaway, the third one, memory engineering is continuation. The first one was prompt engineering is maximization. Second, context engineering is optimization. And memory engineering is continuation. Do you guys get it? That's good. Okay, so there's a lot of words, but there's code to this. I showed some folks yesterday, but you can but you can go on GitHub and type in memories, and you will see this library that I use as my playground to explore some of this area and bring to you abstractions to allow you to play with, to understand memory in a sense. I'm also doing, some people are taking pictures. Okay, I have a clicker that I'm not using. I'm using it now. So I'm also doing this thing on LinkedIn called 100 Days of Agent Memory. I'm on day 60. Today's day 60. So you can go back and look at things I've spoken about, or you can just keep following. You can follow me on this journey as I explore this space, because it is a journey. So day 60, hopefully we make it by day 100, to day 100. But the key thing is, today some of you have the seed to close this gap, or at least move people from one area of this Gen AI divide to the other. So if you want to move people from the 95% and get them to the 5%. And as a bonus, I'm thinking about two things, and this is the bonus part to the slide. I've got a few more minutes left. There are two ideas I'm thinking about. One is application mode, and one is the agent stack. So I'm going to go through them very quickly. With application mode, I'm seeing that there's a pattern across all of the agents that we're developing, and they fall within three particular patterns. So an agent might have one or more of this. It could be a spectrum. You're either building an assistant, a workflow agent, or a deep research agent. I've described it there, but I just wanted to share that with you. So it really helps when you're thinking about memory to think about what am I building and what memory type would associate with the application mode I'm building. For example, a workflow agent does not need conversational memory. All you need is execution of sequential steps or parallel steps. A deep research agent might need more of even all of the memory that we've spoken about. So the second thing is the agent stack. I'm going to go through this very quickly. I'm just going to click through. Here we go. There's the application stack. And this is essentially the key layers that I see are very important for us to get right when we're building agentic systems. So this is the blueprint of making sure we're building reliable, production-ready agentic system. The important bit is the memory core. If you're an AI leader, you're going to get the slides. I'll take it back, take some pictures. Go on. You're taking it? Okay, cool. If you're an AI leader, you can look at two parts of this. The top part and the bottom two parts. So the application and the interaction layer. Because you want to actually think about what your customers are experiencing. That's the application layer. But if you're a leader within a large organization or small organization, you also have to be thinking about your infrastructure and your memory core, because that's the foundation of your entire business. So if you want to take a strategic view on it, I'm not saying you don't think about the rest, but those are the key areas you focus. If you're an AI leader trying to think about where do you want to invest, well, you invest in the application where your customers see, you invest in the infrastructure as well, the foundation, but you also have to pay particular attention to your tooling. I'll be done in a second. And customer experience, these are the areas I think you should be focusing on. Of course, we can debate this as well. And I would miss it if I didn't mention the fact that I'm at Oracle, and I've been in Oracle for about 2.5 weeks, which is a long time in AI. But when I got to Oracle, I was so excited. Because when I opened the package, there were so many toys to play with that aligned with all aspects of the agent stack, right? So I work in Oracle Database, which is the memory core. But there are other areas of Oracle's products and features that really give developers tools and features to actually start to build efficient, security graded or efficient and actually secure AI agents. Agents that are reliable, believable, and capable. And this is the last slide of my talk. So you're going to be hearing more from me. Feel free to follow me on LinkedIn, or you can come talk to me after this. Thank you very much for listening.